Welcome, this is Emmett, and in today's video we'll be tackling this problem. For more unique problems Mari and I created and solved, visit the link in the description and check out the rest of our videos. Okay, so there's a wooden plank inclined 30 degrees. 10 feet up the plank is a circular wheel with a radius of 1. If a dot is drawn on the part where the wheel is initially touching the plank, what is the maximum height of the dot as the wheel rolls down the plank? And we're also given this information about cycloids. So pause, try it out, and get back to the video when you're ready. So here I've provided what a cycloid looks like in the XY plane, and I've also drawn a little setup of the ball on top of the plank. And so visually, the solution is going to be this cycloid shape rotated 30 degrees. So the particle follows roughly this path here. We also know that the maximum height is going to be where the tangent line up here has a slope of 0. However, finding what the rotated parametric equations are is tricky. Because of this, we can instead rotate this entire picture here so we can deal with the provided parametric equations initially. As you can see, everything in this new image has been rotated 30 degrees. And what we need to do is now find this rotated point up here and then consider where that is in the original unrotated setup. So I've made everything bigger so that it's easier to see. So firstly, this angle right here, this angle here, is going to be 30 degrees, since this angle here is 60 degrees, and this entire thing here is a right angle. Now we need to find what the slope of this line right here is, because with it we can then see where the cycloids dy dx is equal to the slope of this line, which will then allow us to find where this point is here. And so to find the slope, we need the change in y here over change in x. And what we can do is get the tangent of 30 degrees, which will give us y over x, which is what we need. So tangent of 30 degrees, which is also pi over 6 in radians, equals root 3 over 3. And so this right here is the slope of this line. Now that we have this slope right here, finding where the cycloids dy dx equals root 3 over 3 will give the theta where the tangent line to the curve happens to be this same line right here, meaning that we can then plug in this theta that we're going to find into the parametric equations for the cycloid, and it will give us this point right here. So to find dy dx for a parametric, you can do dy d theta over dx d theta. And so that's going to be d theta of the y component, which is going to be 1 minus cosine theta, since r is just 1. So let me write that d over d theta of 1 minus cosine theta over d theta of the x component, which is theta minus sine theta. So let me write that. And so differentiating, you should get that dy dx for the cycloid is sine theta over 1 minus cosine theta. Now, using a graphing calculator, I see that sine theta over 1 minus cosine theta equals root 3 over 3, the slope of this line here, at theta equals 2 pi over 3. And note, on your calculator, you can treat theta as x. So this means at 2 pi over 3, the slope of the tangent of the cycloid right here is root 3 over 3, which is the slope of the line right here that the maximum is on. So if I plug in 2 pi over 3 into my two parametric equations right here, I should get the coordinates of this point right here. So to find the x coordinate, we're going to plug 2 pi over 3 into theta minus sine theta. So that's going to be 2 pi over 3 minus sine of 2 pi over 3. And for the y coordinate, we're going to plug 2 pi over 3 into 1 minus cosine theta. So that'll be 1 minus cosine 2 pi over 3. And so solving for these, you should get that the coordinates are 1.228, 1.500. So bringing back the visual and also bringing some blue, we now have the coordinates for this point right here. Keep in mind that's assuming that this is the origin right here, this is the x-axis, and this right here is the y-axis, which is only temporary, so that we can work with the standard unrotated cycloid equations. With this point right here, what we're going to want to do now is find this distance right here, which will be useful for finding the unrotated point. So let's do that. Which equals 1.9386. We can also find this angle right here, which will also be useful. So we can find this by using inverse tangent. Because we know the tangent of this angle is y over x, which is 1.5 over 1.228, we can do inverse tangent to get the angle. And so doing that, we'll take the inverse tangent of this. We get 0.88478 radians. So now we have this number and this number that we'll bring back into the original drawing. So we can now bring these two numbers back into our original unrotated setup, and hopefully you'll see why we did all that. I also added this blue line right here to help with what we'll do. So for starters, we just found that this distance right here from the starting position of the particle to the position at the maximum height, this distance right here is 1.9386 feet. And we also found that this angle right here is 0.88478 radians. So we need to find how much higher this dot is right here from the starting position. If you see here, there is a triangle that can be created, right? And if we can find this little angle right here, this angle right here, then we can then find the leg of this triangle, which will be the height change. To do this, let's first recognize that this angle right here is 30 degrees, since this is 60 degrees right here, and this whole thing is a right angle. So this angle here is 30 degrees. And we also just labeled that this entire blue angle right here is 0.88478 radians. So if we want just this angle here, just this angle, the little red angle, then we can subtract 30 degrees, or pi over 6 radians, from 0.88478 radians. So let's do that. And subtracting, we get that this equals 0.36118 radians. Now we can work with this little triangle that I've drawn bigger here. So we know that sine of 0.36118, the angle, is going to equal y over 1.9386, which is the hypotenuse. And so multiplying both sides by 1.9386 and evaluating, you should get that y equals 0.685. This means that the y value at the maximum height, this point right here, is 0.685 feet higher than the original starting height, which, as we see here, is 5 feet. So therefore, the maximum height of the particle is 5.685 feet. So if you've made it this far, thank you for following along. Although it may seem like this problem was straightforward for me, it took a lot of trial and error to figure out how to get the answer. So have a great day, and thanks for watching.